Welcome once again for to this lesson. We are handling the unit Information System Analysis and Design, following the ABMA syllabus. And today's lesson, I want us to look at outcome one. I want us to look at the first outcome. And in this first outcome, we are going to learn about how we can analyze common life cycles as they are used in managing information systems. How to analyze or analyzing how common life cycles are used to manage information system projects. This is the first requirement outcome when it comes to the ABMA syllabus, and I have my resource here that contains detailed notes, detailed information that you can actually rely on. Now you can get these notes. Yeah, as you can see, they are detailed, so many of them. You can get these notes. Apart from these resources, we also have a system that we are actually running, and this system is an educational system. So you might be interested in other courses that you want to learn online. Currently, we have a course in ethical hacking that is going on. The cost is cheap. You pay a monthly subscription of 2,000 per month, and you learn practical skills from zero to hero. So to get our other courses, we also have free resources. We have past papers for ABMA. You download past papers and you buy marking schemes. To get all those resources, I'll put the link in the video description, but you go to Bonafide College, bonafidecollege.co.ke, and you click on Bonafide College. Now this is our website, as you can see. So our website, we built this website by ourselves. This is our own work. So we are people you can trust when it comes to offering skills, because all you see here is our own work. This is our own work, and this is a fully functioning website that is live. And now the most important part that I wanted to highlight on is this here. You have this course here known as ethical hacking. The course goes for 2,000. Now this 2,000 is a monthly subscription, so every month you pay 2,000 and you continue learning. You learn ethical hacking. We'll be uploading videos, quizzes, etc. That are guiding you through all the steps. And we have also live chats where you can communicate with the person, with your teacher. We also have this course that is ongoing right now, JavaScript from zero to hero. It has 3 students. We have 3 students for this course. We have 8 students for this course. Then we have other free resources. We have these past papers. This is Web Technology ABMA past papers. This is a free resource. You just need to enroll there and download the past papers. Now what you do is you can actually buy you get free past papers, but if you want the marking schemes, you buy the marking schemes. And that's why you see here, learn easy, excel easy, free. You have free past papers. You get free past papers and buy our marking schemes. Of course, there is a WhatsApp number there. You can actually WhatsApp and say the marking schemes you would want to buy. Each paper, the marking scheme for each paper is just 50 shillings. Just 50 shillings. Okay. So these are free resources that are here, and I'm going to release many other free resources. So just become our member. Just become our member by making sure that you subscribe here, so that we can give you some special offer and course updates. Then you subscribe to our email listing here. You come here, you supply your email, then you click sign up. Yeah, we have so many other courses that we are actually launching. We have web design, we have computer programming, we have machine learning, film production, courses that are still under working. Now, maybe you are also you are a trainer. You are a trainer. We also have a slot for trainers. If you come to pages here, you can come to here. We have instructor registration. So you can come here and register as an instructor. When you register as an instructor, and we allow you create courses, and whenever your courses are purchased, um, the system takes 90%. You take 90%, the system takes 10% out of the total amount of money that you will have made from selling the courses. So you can register as a student also. We have our blog. You can visit our blog and keep learning. We update this blog on daily basis, especially with technological trends. You can visit that. Now, the most important area that I wanted to focus on was courses, because I'm trying to show you how you can actually access these courses. So we have ethical hacking. Um, uh, we have these free resources. We have a portfolio website. We have 2 students. Then we have this one, uh, level 4 ABMA Computing and Information Systems. This has 3 students. Then we have information presentation analysis, the past papers. Now, one person just downloaded. This one is hasn't been there for a very long time. Yes. So now this way you can get more courses, can get more information. So maybe you are enrolled in a college, you're doing ABMA, but or you're doing maybe computer programming, but you don't have time to attend all the lectures. You can still come up and catch up here. Just get yourself a course. Now let's go back to our to what we were actually talking about here. So we are going to talk about the common life cycle models for system development. So you're going to talk about the waterfall model. We're going to talk about the spiral. We're going to talk about other models like the iterative model uh, and so many other models. Now in these models, I'm going to, like you can see, this resource contains a lot of information that is necessary to the students. For me, I'm just going to guide you through. In other words, I'm going to just tackle the key things. I'm just going to start to tackle the important things, especially for example, in waterfall. I'll talk about what waterfall model is. I'll talk about the usage of waterfall. I'll talk about the principles in waterfall model. Then I will also talk about maybe advantages and disadvantages. Those are the major areas that I will be focusing on, and also I'll touch on the phases. Okay, so SDLC, which stands for Software Development Life Cycle, is actually a combination, or we can say it is a series of phases. A series of phases means we have when we say series, it means if you watch movie series, you have episode one, season, maybe season one, episode one, then season one, episode two, something like that. So it's something that follows a phase to another phase, or an episode to another episode in a sequential order. So when we talk about software development life cycle, we're actually talking about a series of those phases that are actually giving a common understanding of what the software building process. So when you're building a system, then there is that that common understanding that you need to get as you flow through in the designing and the development of the system. Now, uh, it actually focuses on how you are going to realize that software, how you're going to actually develop that software. Of course, from the very first steps of you understanding the requirements of the software, understand the business, understanding the requirements of the software. Then you convert those business maybe ideas into requirements, then requirements into functions, then functions into features, until now you have a system that can actually is fully functioning and can actually be used to solve maybe a business problem or to handle a business need. So a good software engineer should be a person that has good knowledge on how best to choose the software development life cycle model. Of course, the choosing of the software development life cycle model will depend on the context of the project. It will also depend on the requirements of the project. What are the business requirements of the project? What is the context of the project? Now, it is very important that you choose the right SDLC model, and in choosing, of course, you need to look at the specific concerns, the specific requirements to ensure that the project is going to be a success. Yeah, so in this lesson, we are going to look at different types of software development life cycle models, going to look at the advantages, going to look at the disadvantages, and we're going to look at when do we use these models, where are they used. We're going to look at those major three areas. Okay, so when you look at SDLC, you can actually think of it as a tool or tools that you actually use to deliver your software project in a better way. They're like tools that you use to deliver your software project in a better way. Imagining you have a software project and you don't have any model to follow, then it will be confusing because you don't know where to start from, you don't know where to move to next, and all that. So you need to know and even understand every model, like all the models that are used here, so that it is going to help you when you want to choose which model. Understand the advantages of each model, understand the disadvantages of each model. It is very important to also know that where does this model, where is this model suitable for? In which context do we use waterfall? In which context do we use spiral, for example? Which context is spiral more suitable? Which context is in which context is waterfall model more more suitable? So the first type of software developing life cycle that I'm going to look at is the waterfall model. I'm going to look at the waterfall model. Now, the waterfall model, just like water flows, is actually in a linear sequential flow, in which here we see the progress of the project going or flowing steadily downwards, okay, throughout the phases. Now, what means here is that any phase that we have in the development process is going to begin only if the previous phase is completed. Because now we are talking about water, like water flowing. Let me just show you something. Now, we're talking about a water flow model. So water is flowing. Now, you can see this is how water flows. Something like that, you see? Something like that. Now, what it means is until the water droplets has passed this stage, they can't come to this stage. Until the water droplets have passed this stage, they can't come to this stage. So what I simply mean is that in this model, for you to begin the second phase, you must have completed the first phase. You must have excuse me, you must have completed the first phase. For you to begin the fifth phase, then you must have completed the fourth phase. That's what I'm really talking about here. Okay, it is an approach that actually does not define a process known as going back to previous phases, maybe to handle some changes in the requirements. I'm just going to use an example here. For instance, I want you to design a shopping system for me, and I said I want you to include a shopping cart in there, and let's say maybe a payment method. And I said for the payment method, I want you to use a direct to bank, or let's say I want you to use PayPal payment method. But I realize that most of my clients are in countries that actually PayPal is not supported, or they they find difficulties when it comes to doing transactions with PayPal. So before the project or the software is completed, I realize I do not want to implement I did not want to implement maybe direct to bank or PayPal. I want to implement M-Pesa. You see, when you are using the waterfall model is going to limit that you going back to a phase. Maybe we already implemented the payment. We implemented the payment method. So it limits you going back to a phase so that you can handle what is known as a changing requirement. It prevents you from going back to that particular phase. So once you have you have actually completed a phase, you move to the next phase, it does not allow you to go back. In other words, we say one of the principles of waterfall model is that it assumes the requirements are frozen. You cannot actually go back, you cannot change the requirements. Once you're done, you are done. Okay. Now, the waterfall is actually one of the, actually not one of the, but it is the earliest approach, and it is also widely known. It is also widely used by software developers in the software development industry. And the phases, just like I'm showing you here in the diagram, the phases are actually moving that way. Now you can see it's like water flowing. That's why it was given the name water flow. So from the requirements phase, then you go to the design phase, the execution phase, then the testing phase, then we go to the release phase. Here is where we now deploy the software to the environment for use. Okay, so what I'm trying to say is maybe we are done with requirements here analysis, we are done with designing, and we are now in execution. When you're using the waterfall model, we are in execution, then we realize that one or maybe the client wants to change some requirements. When you're using this phase, it cannot allow you to go back to the requirements phase. Once you're done with a phase, that's it. It limits you from going back to that phase. It limits you from going back to that phase, something that you need to understand. So where do we actually use waterfall model? So waterfall model is basically used in two scenarios, or maybe in two scopes. The first one is when you have a project that actually does not have the likelihood of changing the project requirements. You have a project that without the likelihood of changing the requirements, once the requirements are defined and documented, it's done. Then waterfall would be the best for that. So the first one, it is used in projects that do not focus on changing requirements. And I've given an example here of projects that are actually initiated from a request for RFPs proposals. So here, when you have projects that are actually is a request from RFP proposal, then it means that we have requirements that are clear, and they're not just clear, but they are documented. You have requirements that are clear and they are documented. So if your project, if you are focusing on a project that one does not focus on changing requirements, then you would settle for waterfall model. If you are working on a project that has requirements that are clear, requirements that are clearly defined, and requirements that are clearly known, that are clearly documented, then you would settle for waterfall model. Those are the two areas where waterfall model is actually used. Um, is actually used. Now, there are several phases. There are several phases in waterfall models, starting from the requirements analysis. Now, the requirements analysis is actually the first phase in waterfall model, and here we are going to come up with a deliverable, which is actually the requirements specification. Here, we are going to identify the requirements, we are going to analyze the requirements, and we come up with a document that is actually the requirements specification. Now, once we have known the requirements of the project, then we move to the next step, where is actually now doing the software designing. So here we are deciding how the software is going to look. If we are designing maybe a website, how are the pages, how is the web page going to look? We are actually showing the interfaces of the software. We are actually showing the user interface of the software. Now, once we are done with that, this is the second phase. Then we move to the third phase, and the third phase is implementation. In implementation here, we are actually converting that software design into a real system now. This is where coding comes in. Programmers come in. They write code to actually convert the proposed design into a complete system. Now, once we have our software implemented, we need to make sure that whichever software that we have come up with here then is actually working the same way that we wanted it to work. We need to make sure that the software that we have come up with is able to actually handle all the requirements. We have taken care of all the requirements. If we need to have here a login, then customers are able to log in. If we need to add things to cart, things are added to cart, remove things from cart, view things from cart, all those things are actually happening. We need to do testing to confirm that the software is actually working the way we expect it to work. So we do testing, and in testing we supply data into our system and check how it actually works. Now, after confirming that we've done the testing and the software is good to go, it is working, all the requirements are taken care of, then we are going to do integration. Now, integration simply means we are bringing in some other subsystems, some subsystems together. We are bringing subsystems together. Yeah, that is if there are many, if we have multiple subsystems. But if it was just one system, then we are not going to deal with integration. Now, integration can also mean integrating maybe, let's say, for example, payment systems, let's say, working with databases and everything here. Then from there, we are going to deploy or install, deploy or install. Here, we are releasing the software now to the live environment. We are releasing it to the market for people to use it. Yeah, we are releasing it to the market for people to use it. If you are designing it for a client, maybe an organization, then you are actually installing that software in the organization for people to use it. And after that, maintenance, we need to keep on maintaining the system over and over again. Just like we maintain cars, we need to maintain softwares. Now, the first description that actually brought out the idea of waterfall was in an article by that was written by somebody known as Winston W. Royce in the year 1970. But here, Winston W. Royce did not actually give it the name waterfall. Yeah, he did not give it that writing the name waterfall. But if you look at his writing, the description of his writing and how the waterfall actually works, we see some principles that are actually basic, both from his writing and actually in the waterfall model. So we have principles of the waterfall model that actually work, and one of the principles is one. We have to divide the project into sequential phases. So the project is divided into sequential phases. Then these phases are able to overlap, and they can also splash back. We have that overlap and splash back acceptability between the phases. Then we put emphasis or waterfall emphasizes on planning. Waterfall emphasizes on planning. In planning here, we make time schedules. We make time schedules. When are we going to start phase one, and when are you going to finish it? When will phase two start? When are we going to finish it? We put in we put time schedules. We put target dates also. We are beginning this phase, but after 2 weeks or 3 weeks, we need to be done with this thing. Yeah, we put target dates. Then we also plan budgets. How much do we need? What is the software need? What is the hardware need of actually the implementation of this project? And how much do we actually need? Yes, so it focuses on planning, time schedules, target dates, focuses on budgets, and focuses on the implementation of the entire system at one time. Here we are just dealing with having that system installed and running at one time. Number three, the third principle is that in waterfall, we have tight control that is actually maintained throughout the project. And this type control is maintained through we have extensive document writing that is actually happening here. We have extensive documentation. So from the requirements phase, we get a document that is actually showing the system specifications. We move to another phase, we get a document from that. Like in the design phase, we have a document that is actually showing, explaining and showing the proposed design. So almost every phase here has a document. So there's detailed, there's extensive written documents here. There are extensive formal reviews people need to keep on reviewing the documents. Your client will keep on reviewing the document, and then the client is going to sign off. He's going to give a go ahead. This is okay, continue, or this is not okay, change one or two, 1, 2, 3. So we have that documentation. Then you have formal reviews by maybe the clients, or maybe project managers or the stakeholders. Then we have the approval also by the stakeholders. We have the approval by stakeholders. Okay, now moving on. Those are the three principles of waterfall model. We said the first one is we have the project divided into sequential phases. Number two, we emphasize on planning, time scheduling, target dates, implementation, and even budgets. Then we have tight control. We maintain tight control by making sure we have extensive written documents, and we have formal reviews, and we have approval or signing off. Now, we have the advantages and disadvantages of waterfall. Let's deal with the advantages first. Now, the first advantage of waterfall model is that when you're working with the waterfall model, you have an easy way to actually explain the progress of the project or the functionality of the project to the users of the system. Then it follows a structured approach. Yeah. Then we have stages and activities that are well defined. Each stage is known, and under each stage, what activities are actually supposed to be done in that stage. So we have defined stages. We have defined activities under each stage that actually uh, 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 that are actually handled. Now, because waterfall model focuses on planning, time scheduling, focuses on budget and implementation, then when you're using this model, it is going to help you to plan and to schedule the project. That is an advantage. It will help you to plan and schedule the project. Why? Because that is a principle in a waterfall model. Then we have verification at each stage. How is verification done? Verification here is done by the stakeholders. We take the document to the stakeholders, they look at the document, then they sign off the document. So they give you go ahead to continue. And if there are any changes that are supposed to be made, then you're also told. Now, why is this verification at each stage important? It is important because if there is any error or any mistake that is done, or any misunderstanding of a requirement, it is brought up at an early stage. It is brought up at an early stage. So when it is brought up at an early stage, it can be looked at that particular stage without waiting until the whole system is done. Then changes, actually errors are seen. So we have each phase here as an advantage also has a specific deliverable. In other words, each phase has something that comes out that needs to be looked at and needs to be approved. Now on to the disadvantages. The first one is that I've talked about this previously, that the waterfall model will assume that the requirements are frozen. It assumes that the requirements of a system can be frozen. In other words, once we are done with these requirements, we are not going back. The requirements of these systems cannot be changed. They are frozen. They cannot be changed. And that is a disadvantage. Number two, it is very difficult to go back to any stage once you are done. I talked about this when I was describing the waterfall model. Once you are done with a phase, you don't go back. It is very difficult. I didn't say it is impossible. I said it is very difficult to actually go back to that phase when you are following this approach. The disadvantage number three is that it is difficult to actually apply flexibility, to apply what we call adjusting scope. You cannot, the project is not flexible here. You cannot adjust the scope of the project. And if you have to do it, then it is difficult and it is also expensive. Last but not least, this model is costly. It requires more time, and it also requires detailed planning. It is costly, requires more time, and requires detailed planning. Yes, so that's all about the waterfall model. That's all about the waterfall model. If you have any question, you're going to drop it in the comment section, and I'm going to respond to it. Yes, for more clarity, for more resources, I've shown you where to get it, and I'll put the link to the resources in the description below. Okay. So let's continue with the V-shaped model. Now, when you look at the waterfall model, you realize the waterfall model has its own disadvantages. And the major disadvantage is that it limits going back to completed phase, to previous phases. So V-shaped came in, the V-shaped model came in as an extension to actually the waterfall model. So instead of us now moving in a linear way, here we have the processes that are actually bent after the implementation. After the implementation here, we are bending these processes upwards. Yeah, to form this V shape that you can see here. So we have planning requirements, architecture, we have detailed design, then we have implementation. Then this side, we have unit testing. We have unit testing. So we are actually testing this one. Then we are we have integration testing. Unit testing here, we test each single unit of the system. Then integration testing is we are testing those subsystems that we actually connected together. How are they working? Then we look at system and acceptance testing. Of course, here this happens at the requirements. Then we look at the maintenance. We look at the maintenance. So a few takeaways here is that in the V-shaped model here, we have processes that are actually bent upwards after the implementation and the coding phase, and that forms the typical V-shape. Now, there's a major difference between the V-shaped model and the waterfall model, and the major difference is that in the V-shaped we have the early test planning that is not in the waterfall model. I want you to check here. So when you do the requirements here, once you're done with the requirements, we have system and acceptance testing that is happening here. So this is an early testing. I want you to notice something that once you have actually analyzed the requirements here, then you do system and acceptance testing immediately. This is an early testing. This is a major difference between the V-shaped model and the waterfall model. So when we look at the architecture, we have integration testing. When we look at the detailed design here, then we have a unit testing. So I want you to see that is the major difference. That is the major difference. Every phase is tested. Every phase is tested. So we have early testing. We don't wait until the whole system is done for us to actually test the system. Now, what are the scenarios, or where is the V-shaped model used? V-shaped model is used in two scenarios or two areas. One, if you have software requirements that are clearly defined and known. You have software requirements that are clearly defined and known. You know the requirements and they are clearly defined. Then you'll go for the V-shaped. Then you're going to use it in scenarios where you have the technologies and also the tools that are supposed to be used for development already known. So if the development technologies and the tools that you need for that project are known, then you would settle for the V-shaped model. Now, the advantages here: one, it is simple and easy to use. It is simple and easy to use. Again, each phase has a specific deliverable. I want you to realize that this is a similarity between a waterfall model and a V-shaped model. The advantage number two, each phase has a specific deliverable. Remember we said in waterfall model that also each phase has a specific deliverable. So it is a similarity. So in case you are trying to get the similarities between the two, that is one similarity that is coming out. Now, number three, there is higher chance of success over the waterfall model. Yeah, we are more likely to have a successful project when you use the V-shaped model than the waterfall model. And the reason is because in the V-shaped model, we have the early testing plan. Yeah, we have the early testing plan that guarantees us higher probability of having a successful system than in the waterfall model. Then this model works well where we have requirements that can easily be understood. Where we have requirements that can easily be understood, then the model works well in that area. We also have verification and validation of the project in the early stages of product development. Remember, we also talked about verification and validation. So we also have it in V-shaped. The product in the early stages is verified and is validated. So that are the advantages. Now, looking at the disadvantages, the first disadvantage is that this particular way of developing softwares is inflexible. And that is a difference. Huh? Remember, we said in software, we said in waterfall model, it is flexible. Now, flexibility is difficult. So that looks like a similarity. So this one is very inflexible. It is just like the waterfall model. So that is another similarity. The waterfall model, we said flexibility is difficult. It is not flexible because you cannot change the requirements once you're done with the phase. Requirement change is almost impossible to change. And if you have to do it, you're going to spend a lot of money, you're going to spend a lot of time. Yeah. So the V-shaped model is also inflexible. Then adjusting the scope also here is very difficult. It is also expensive, just like in the waterfall model. Okay. Again, we have the software here that is actually developed during the implementation phase. So we don't have early prototypes of those softwares that are actually produced. Then this model, it does not give a clear path for problems that are found during the testing phases. You see, you are in the requirements, you find, maybe you identify a problem. There is no clear path that states how you can actually navigate through that project as you go on the project. That is a disadvantage. The other one is that it is costly, it also needs time, it also needs a detailed plan. That disadvantage is similar in the waterfall model. So on to the prototyping model. Now, prototyping model, actually, if we look at it, we are going to simply say that when we are using it is a model that actually involves creating of prototypes of a software, maybe application. We create incomplete versions of the software program that is being developed. Then we look at that the incomplete version. We look at what problem it has. We improve it. We improve that particular version. Okay, so prototyping is actually an activity that it has the probability of occurring. Actually, it occurs in software development, and we normally use it to make sure that we are able to visualize the component of the software so that we can limit that difference or that gap of actually misunderstanding the customer requirements. We do not want to actually have a higher probability of misunderstanding customer requirements. So we design an incomplete version, maybe a first prototype that is an incomplete version. Then we look at that incomplete version. What does it lack? What doesn't work well, and what does it lack? Then we improve it, and when we improve it, the result of that is actually a second prototype. Now we are doing that to make sure that we are narrowing the gap of misunderstanding the customer requirements, that the team will be able to really understand the customer requirements well. Apart from just reducing the gap, we are also trying to reduce what we call iterations. Now, you realize in waterfall model, there can be a lot of iterations, yeah, and that is going to be really hard when it comes to implementation because of its inflexibility, yeah. So here we are trying to actually to reduce the iterations. Like iteration simply means doing the same thing over and over again, repeating the same thing. So when you have the final software, the final prototype, the final incomplete version of a software, or the final complete version of a software developed, then here we freeze the requirements, or we consider the requirements frozen. Now we are done, we cannot change these requirements, and we are just sticking to that. Now there are a number of types of prototyping. We have different types of prototyping. I'm just going to look at a few. And the first one that I'm going to look at is the throwaway prototyping. Now, in throwaway prototyping, just like the name suggests, once you have created a prototype, okay, once you're done creating a prototype and you have actually looked at it, you've seen where to do the corrections, that prototype is not becoming part of the system. We are actually not using that prototype into delivering the final software. Like, we are not taking that, then work on it and improve things, then we use it. We are throwing it away. We are discarding that particular prototype. So in throwaway prototyping, the prototypes are finally discarded. They don't become part of the final software that is delivered. We discard them. That is for throwaway. Then we have evolutionary prototyping. We have evolutionary prototyping. Now, evolutionary prototyping, we have prototypes, and these prototypes are going to evolve into the final systems, of course, following an iterative approach and also looking at the user feedback. Let me explain this deeply. Now, you create the first prototype. Remember, in throwaway, once you create the first prototype and the user has looked at it, you've gathered feedback from the user, you throw it away. You don't actually use it. But the opposite of that is actually the evolutionary prototyping, where you take that particular prototype, you consider the user feedback, then you improve that same prototype. So one prototype is going to evolve throughout that particular process by improving it every time to actually respond to the user feedback to the latter. So it is the same prototype that is actually going to be delivered as a final product, but it has undergone series of improvement. So for example, we look at this here. We have requirements gathering. Then requirements gathering, we go to analysis. So when we go to analysis, we develop a prototype. So this is our first prototype. Let me just call it P1. We develop our first prototype. So once we have developed our first prototype, we take it to the client for evaluation. The client evaluates it and, of course, gives feedback. Yeah, it's going to give feedback on what needs to be improved. So we have the suggested improvement here. When feedback is given on what needs to be improved, then that same prototype is actually taken from this part, analysis. So analysis is actually happening considering that same prototype on what needs to be done. Yeah, but if the client evaluates it and sees that there's nothing to be improved, then we can move from analysis and we go to design. The same thing is happening in the design. If there's an issue, then we need to follow this same procedure here that I have really shown. But if there's no issue, we move to the next, we move to the next, we move to the next, we move to the next. So what you need to know here is that we can have iteration. We can actually have iteration happening in here in evolutionary, but depending on the user feedback. So we don't throw away the prototype. The same prototype is actually changing, or we improve it until we get what we want, until we get a software that meets the requirements of our user. Now the other one, the other type of prototype is incremental. The other type of prototype in incremental. Okay. Now what happens is in incremental is we have the system. We divide that system into various, or we actually build different prototypes for that particular system. We build different prototypes for that particular system. Then, for example, if we are dealing with an e-commerce site, we can build a prototype that deals with maybe the store. Let's say maybe we build the store, then we build the shopping carts and everything. Then we test them independently or separately. After testing them separately, then we join them together. We bring them together to form the complete system. That is why we call it incremental. So we have a final product that is actually built from separate prototypes. Separate prototypes are built, then in the end we actually merge all those separate prototypes to form the overall design. So if we look at this now, here we have planning. From planning we go to analysis, then we go to design. Now in design we can develop a prototype, another prototype, another prototype. So these are three different prototypes. After developing them, we test them independently or separately. We test them independently or separately. Now, once we are actually satisfied with these prototypes, then we actually merge them. We actually merge them into a complete system. You can see here. So when we maintain them as one system. That is incremental. Then we have extreme prototyping. Extreme prototyping is majorly used when you are designing web applications. Now this is because it is actually having a concept of breaking the web development process into three phases, and each phase there is going to be based on maybe a preceding phase or the first phase. Now the first phase it normally is what we call the static prototype that mainly has the HTML, the hypertext markup language pages. Then you have the second phase that is actually programming the screens. We want to make sure that we have fully functional screens here. By programming screens, I mean the website is going to look good regardless of the screen size. Then we move to the third phase, is where we implement the service. So if you actually did web technology, you have seen this approach. You have seen that approach. Now, specifically for the students I taught web technologies, this is the approach we followed. Now, where is this particular SDLC model used? Yeah. Now, one thing you need to know is that we can use this model with any software development. We can use this process with any software development lifecycle model. But while we are going to choose this, we are going to choose this particular model if we are actually working on a system that that has user interactions. In other words, users are going to interact with the system either by inputting data or by for example, if it's a website, users, we create websites for users to interact with. So if you have a software that users are going to interact with, then this will be the way to go. This will be the way to go. Now, if the system does not have user interaction, for example, some systems that actually does some calculations, then we don't need to have. It is not going to have prototypes. You don't need to have prototypes. So just put that in mind, that if the system has user interactions, then it's going to follow that. Now, what are the principles that are actually used? What are the principles that are actually looked at when it comes to prototyping? What are the principles that are used when it comes to prototyping? One, the prototyping model is not a standalone. It is not you cannot completely look at it as a methodology for system development. Yeah, it is actually an approach that is used to handle maybe some selected parts. When you're dealing with a bigger project, then we use it to handle some selected parts of that project. Yeah. For example, we can talk of incremental spiral, or maybe the RAD. Just handle a section or a part of a bigger project. So it is not, you cannot say for this project I am using prototyping. Prototyping cannot be used alone as an SDLC model. So prototyping also is attempting to make sure that there is a reduction in project risk. There's a reduction. It reduces project risk, and it is doing that by making sure that the project is actually divided into some smaller parts. We call them smaller segments. When we have the project divided into smaller segments, then it means we have we have ease of changing those particular segments as we develop. Yeah. If you are working on a smaller part of something, then it's easier to actually change that part than changing a bigger part. Then also it has a principle of involving the involving the users. Yeah, users are involved throughout this particular process, and this is going to increase the probability that the user is actually going to accept the final implementation of the system. Because if the user saw the first prototype, approved it, saw the second prototype, approved it, now it is the third prototype, which is the last prototype, then most likely the user is going to accept that implementation. Then it has small scale mockups of the system that are developed following what you call an iterative modification process, until then we have the prototype that evolves to meet the user requirements. Now, most of these prototypes are developed with the expectation that we're going to throw them away, we're going to discard them. So maybe as a developer, most of the time you would want to develop something, you would want to develop a prototype with the intention of actually throwing it away. While that is the case, there's a possibility that in some cases we have prototypes that are going to evolve from maybe first stage to becoming the final system. I talked about that evolutionary prototyping. So another principle is that there is need for a basic understanding of the fundamental business problem that is going to help you to avoid solving maybe a wrong problem. You need to understand, you need to have a basic understanding of the business problem to make sure that you are solving the right problem. On to the advantages. Here we have reduced time, we have reduced cost. Yeah, reduced time, reduced cost. But at times this can be a disadvantage if you as a developer, you waste a lot of time in developing the prototypes. Then you see that is going to be a disadvantage. Number two, we have improved and increased user involvement. Of course, we said we involve the user in all the stages. We get their feedback and we alter the prototype where necessary. Then since we actually show prototypes to the clients, then the client get a clear understanding. They actually get a complete feel of the real system. They already know how the system is going to function because they have handled prototypes of that same system. Okay, so another advantage is that it reduces the risk of failure. Now the reason as to how it reduces the risk of failure is because since we have prototypes developed at early stages, then it's easy to find problems at early stages and actually fix them at that early stages. Then there is communication between software development team and the clients, and because we have good communication here, then it is going to provide a good environment. The environment is going to be good. The working environment is going to be good. It is going to be conducive for our developers because we have good communication between the clients and actually the development team. Again, it helps in gathering the requirements. It helps in analyzing the requirements. Now, in the case of when we lack enough documents that actually contain the requirements for the system. A few disadvantages, and the first one is that we have insufficient analysis. And when we have insufficient analysis, then it means the user can actually confuse a prototype with a finished system. You can give them a prototype and they think this is how the system will be, and that is going to bring confusion. Again, so we have there can be a misunderstanding of user objectives by the developers. That is another disadvantage. Then it requires excessive development time of the prototypes. There is excessive development time of the prototypes, and then it is also costly to implement those prototypes. It is costly to implement those prototypes. Again, that's it with prototyping. You have a question, put it in the comment section. Now, the other thing that we're going to look at, the other model that we're going to discuss is the spiral model. Now, the spiral model is actually a combination of both it will combine elements of both design and even prototyping in some particular stages. And the reason as to why this is actually happening, then we are actually trying to combine both the advantages of what we call the top-down and bottom-up concepts. Yeah, so it is actually combining the features of the prototyping model and the waterfall model. Hope that is clear. The spiral model combines both the features of the waterfall model and the features of the prototyping model. And the reason as to why we are doing this is because we want to take an advantage of both the top down means waterfall, then the bottom up concepts also. So the spiral model is actually used or favored for large and expensive and complicated projects. When you have a large, you have an expensive, you have a complicated project, then this model favors that particular project. This model favors that particular model. So it uses many of the same phase, just like those of the waterfall model. Um, the phases appear essentially also in the same order, but they are separated by what we call planning. We have the risk assessment, and we have the building of prototypes and simulations. Now, the areas where it is used, like I have said before, it is used in large applications and systems. Yeah, large applications and systems that are actually expensive and complicated. Also in systems that are actually built in phases or in segments. If you have a large system and you want to build in segments, then you would fall for the spiral model. So it has basic principles, a number of them, and the first basic principle is that the spiral will always focus on risk assessment. It will focus on risk assessment and also minimizing the project risk. Now, how is this minimizing? How is this risk assessment? How is this minimizing the risk of the project done? It is done by making sure that the project is broken into smaller segments. The project is broken into smaller segments. So when you have the project broken into smaller segments, like I was teaching in prototyping, then you're going to have an ease of change during or throughout the development process. Yeah, this will also provide an opportunity to make sure that you are able to evaluate the risk that are actually going to come up with that project. You're going to actually take some quality time to weigh the consideration of maybe the project continuation. Should we continue this project? Should we actually drop this project? So it is going to help us in that. Now, the other principle is that in each cycle of the spiral model, it is going to involve what we call a progression. We have a progression through the same sequence of steps. So we have a cycle, but for each cycle, it is going to progress with the same sequential steps. In other words, it's going to follow the same sequence in the same steps in the same order. So for each part of the product here, and also for each level of elaboration, now starting from the overall concept of the orientation document down to the coding of each individual program, here we are going to follow the same sequential steps. Another principle is that each trip around the spiral traverses 4 basic quadrants. In other words, we have 4 basic quadrants in this particular particular approach, or in this particular model. And the first one is the first quadrant is determining the objectives. And when determining the objectives of the system, you also look at the alternatives Instead of us working with this laid down uh, uh, instead of us working on these laid down requirements, procedures, and all that, can we have alternatives? Can we have an alternative for? Sorry for that. It's a network issue. It's a network issue. So it looks at, I was saying that the first quadrant is we are determining the objectives, we are looking at the alternatives of the system, we are looking at the constraints of the iteration, and the second quadrant is going to actually evaluate the alternatives. We have identified, we have determined what alternatives we have. Then we are going to evaluate them. We look at them at a closer space. We're going to identify are there risks involved? What risks are involved? Which alternative is actually the most likely one we can settle down for? Number three, then we have the third quadrant, which develops and also verifies the deliverables from the iteration. And the last one is then we are planning for the next iteration. Now, another principle is that we are going to begin each cycle with an identification of maybe stakeholders. Maybe the stakeholders are actually these people, are the people that are actually funding the system. So we identify who are the stakeholders, what are their win conditions. Okay, at the end of this cycle, what are their win conditions? Because that is what will be guiding us throughout the development process. Okay, now to the advantages. This model estimates, the estimates of this model actually they end up becoming more realistic as as the work is actually going on, because as you go on, then we have important issues that are actually discovered much earlier during the development process. We also have early involvement of developers. They're involved at an early stage. Then we have it manages risks and develops the system in phases, like I said previously. Disadvantages is we have high cost and time to actually have the final product released to the environment. It needs some special skills to also look at the risk or evaluate the risk and the assumptions that are actually made. Then we have it is actually highly customized, and this limits what we call reusability. This will limit what we call reusability. So again, if you have a question, you drop it in the comment section. We are going on well. So I want us to look at another model, another SDLC model. And this SDLC model is iterative and incremental. The iterative and incremental model. Now, the iterative and incremental model, it was developed because there has been an identified weakness of the first model, which is the waterfall model. So the main aim of actually coming up with this model was to overcome the weakness of the waterfall model. And this model begins with initial planning, and it is going to end with deployment. Sorry, it begins with initial planning and is going to end with development. Now, we have a basic idea behind iterative and incremental, and the basic idea is making sure that we have a system that is being developed through repeated cycles. That is what it means by iterative. Repeated cycles. We have steps. We are repeating the same steps. That is iteration. And then we are not just going to develop the whole system in repeated cycle, but we're going to split that system into smaller portions. Yeah, we're going to split it into smaller portions. Sorry, at a time, and splitting the system into smaller portions is what we call incremental. Then we're going to allow the software developers to actually take advantage of what they actually realize and what they learn during the development of some parts of the parts they developed earlier, or maybe the versions of the system that they actually worked on earlier. Yeah, so we have some mini waterfalls or mini V-shaped models when it comes to iterative and incremental model. Now, where is it used? It is used in what we call shrink wrap application and large system that are built in small phases or segments. If you have a large system that needs to be built in small phases or segments, then the iterative, the incremental becomes one of the model that is also important. It can also be used for systems that have separated components. An example that could be an ERP system. Okay, so on to we can group iterative and incremental development into a number of phases, and the first one is the inception phase. So you can group the development process into a number of phases, and the first one is the inception phase. The inception phase is going to deal with the scope of the project. It's going to look at the scope of the project. In which scope does this project lie? It's going to look at the requirements. What are the requirements of this project? And it's going to look at what are the risks that are actually involved at higher levels in this particular project. Then we have another phase, which is the elaboration phase. Another phase is the elaboration phase. The elaboration phase is going to give us a working architecture. And this working architecture is going to actually moderate the risks that we actually identified in the inception phase. It is going to satisfy what we call the non-functional requirements. Then from moving from the elaboration phase, now we walk to the construction phase. In the construction phase here now, we are filling in the architectural components, of course, following the incremental way of production. We have ready code that are actually incrementally featured in. We have implementation, the designing and the testing of the functional requirements of the system in this third phase. Now, the last but not least phase is the transition phase. And in the transition phase, the system is actually delivered to the operating environment. We now release or we deploy the system to the environment where it is supposed to be used. So those are the phases, the four phases of this iterative and incremental phase. Okay, now we said that iterative and incremental phase was built to overcome the weakness of waterfall model. So we need to contrast it with the waterfall development. Yeah, we need to contrast it with the waterfall development. So we're going to look at the contrast of iterative and incremental model with waterfall model. Okay. Now, one thing that you need to know is the main reason as to why we have software development projects failing is because because of the choice that the developers make when it comes to what project, what model to use. You choose the wrong model and that model is not going to work for you, then that it means you're going to have a failing project. Yeah, so you need to make sure that when you are making a choice for the model to use, then you are doing that with great care. You're doing that with great care. Now, we want to compare the two approaches, and the two approaches which are iterative and incremental versus the waterfall model, because we said iterative and incremental was actually developed to actually counterattack the weaknesses of waterfall model. So we need to look at those two approaches, and when we look at those two approaches, then we have patterns that begin to come out. And the first pattern that we see is user involvement. User involvement. If you look at the waterfall model, we are involving the user in two stages. Which stages? We are involving the user during the requirement stage. We are involving the user during the acceptance and testing stage. So in the requirement stage, we want the user to actually confirm if they accept if they accept the requirements. Okay. Again, we also involve the user possibly when we are creating the user education material, maybe user manuals and everything. Now, when we look at the incremental model, here we involve the client at each stage. That is difference number one. So in waterfall, the user is involved only in two stages. In iterative and incremental, we actually involve the user in each stage. Number two, the pattern number two is variability. The pattern number two is variability. Now, we deliver softwares to actually to the user once we are done with the build stage, or the implementation stage of the life cycle is actually completed, so that the user can actually look at the system and give feedback in terms of if they accept the system or not. So we actually deliver that system for user acceptance and testing. That is now in waterfall. So in waterfall, after the build stage is where now, after the build stage, we are done with the system, then we deliver that system to the user for what we call user acceptance testing. But this is a little bit different, because when it comes to incremental, then we every increment that we actually have is delivered to the user. Yeah. And then after the user approves that increment, or the user approves that prototype, then the developer can move on, can go towards to the next module after that is accepted. So understand that in waterfall we deliver a complete system, while in incremental we deliver each increment for user testing. The third pattern is human resource or human resources. So when you look at the incremental model, you realize that we need fewer staff. We need fewer staff than when we compare waterfall model. Then time limitation is the fourth one. Yeah. In the waterfall model, we are going to have a product delivered after months. After months of the project, then we have a product delivered. But when we look at the incremental, then we can have a product delivered after weeks. We also have the project size, and of course, waterfall model we said is suitable for large and complex projects. Is not suitable for small projects. The incremental can work for both. It can work for both small and large projects. Can work for both small and large projects. So the advantage of the incremental, it produces business value early in the development life cycle. Why? Because the client is able to see something immediately. Yeah, I mean, after few weeks, the client is able to see a prototype. There is better use of scarce resources here. Then we can accommodate some change requests between the increments, because if you release the increment for for user testing, for user acceptance testing, and the user suggests an addition of a feature, then of course it can be accommodated there. So it is more focused on customer value than the linear approaches. What we are actually looking at here is what the customer will get at the end of the project. What value will the customer get? That's what we focus on. Then also we can detect project issues and changes earlier. Yeah, if there's an issue, can come up earlier rather than in the waterfall where we have to complete the project before user acceptance testing is done. Disadvantages is one, there is a lot of documentation. It requires heavy documentation. Then it has a set of processes that are defined and needs to be followed. So it follows a defined set of processes. Then it defines increments that are based on function and maybe feature dependencies. Then there's a lot of customer involvement that is actually required here as compared to the linear approaches. Then we have partitioning of the functions and features. Now, dividing functions and features might at times be problematic. As much as we want them to divide it, then at times it might be problematic. That's why we say it is a disadvantage. Then integration between the iterations then can also be an issue if we don't consider we don't consider it during the development and also project planning stages. It can be an issue when it comes to integrating those particular functions together. So again, that's it. Unless there is a question, you can drop it in the comment section. So for today's lesson, I would like to stop there. And for the next lesson, we're going to look at the agile model, and we're going to proceed from there. We're going to look at the agile model. We're going to also look at the rapid application development. After looking at the rapid application development, we also look at the joint application development. Then we settle on the generic joint application development life cycle. That is for the next lesson. Yeah, so we're going to have an extensive look on those areas. And once we are done with that, I think we're going to finish with advantages of iterative over non-iterative approaches for change management, and that will be it for the last for that lesson. So have a great day. See you in the next lesson.